In this lesson, we're going to take what we've learned in all of our lessons of factoring and put it all together. So when we learned about greatest common factor, I said the first thing you should start asking yourself when you sit down to factor a polynomial is, can I remove a greatest common factor? So that's the question we're going to ask ourselves with all of these questions today. We're going to start there. So when we look at this first one, can I remove a greatest common factor? And the answer is yes. We can take a 10 out. There is not a variable that is in all of the terms, so we do not have a variable as part of our greatest common factor. Dividing each of these by 10, I am left with 2r squared plus 7r plus 6. Now I may or may not be finished. Being able to do this step is a level 3 procedure. Getting to the level 4 is looking to see if I can go further. So I take that trinomial that I have inside my parenthesis, and I check to see if I can factor it a different way. Can I use the box method? Is it a difference of squares? Is there a different shortcut? Because the term in front of the r squared is not 1, I'm going to go right to my box method and see if I can factor this further. Factors of 2 are 2 and 1. Possible factors of 6 are 3 and 2. I get 3 and 4. My middle term is 7. Well, 3 plus 4 is 7. So this can be factored further. The 10 still needs to be written in front of our factors. It is a factor as well. Then I have 2r plus 3, that is my top row, and I will have r plus 2, that is my bottom row. Now I am completed. I have factored this completely. That would be level 4 work. There are 2 types of factoring. There are 2 steps. It's a multi-step factoring question. So in this next example, again, run through in your head. Can I take out a greatest common factor? The answer again in this case is yes. We can take a 5 out. And remember the rule, because we are starting with a negative, let's remove a negative common factor. So I'm going to take negative 5 out. There is no variable in all terms. I'm left with h squared plus 4h minus 12. So again, now I have to check. I might be done, or I might have to go further. 3 terms. I can use the box method, or I recognize that that h squared has a coefficient of 1, so if I remember the shortcut, I can use the shortcut. Shortcut is, I'm looking for 2 numbers that multiply to my last term and add to the middle one. Well, 6 times 2 multiplies to 12, and if I go 6 subtract 2, I will get 4. So I will have h plus 6 and h minus 2. Now if you do not remember that shortcut, we can use the box method. We have 1s. You're going to try 3 and 4, and it's not going to work. So then you will try 6 and 2. We need it to be 4, so you're going to go, oh, I need to go 6 minus 2, and you're going to put the negative with the 2. And you will end up with the same answer. All right, let's factor x squared plus 5x plus 1. So we start asking ourselves, can I remove a greatest common factor? No, there is no greatest common factor in this one. So now I go to one of my other methods. It's a trinomial, so I could try the box method. There is no coefficients on the x squared, so I could use the shortcut if I'm familiar with it. Factors of 1 are 1 and 1. Factors of 1 are 1 and 1. Can I get 5? No. Can I change any of the factors? No. This is a unique type of trinomial. This one cannot be factored. There is no way in the real number system that we can find numbers, and if we think of our shortcut, we want 2 numbers that multiply to 1 and add to 5. Impossible. This type of a trinomial is called a prime. There are no factors. So you think about prime numbers. We talk about prime numbers having only one in themselves as a factor. So a prime trinomial is where you cannot find two factors. (4m squared minus 16n squared). Question you should ask yourself, can I take out a greatest common factor? The answer is yes. I can remove 4 from both of these. Then I'm left with m squared minus 4n squared. Now you should ask yourself, can I do more? I look at what is in my parenthesis. Okay, it's not a trinomial. So now I need to check. I could try the box method where the middle term is 0, or maybe I recognize that that is a difference of squares. Both terms are perfect squares, separated by a minus sign. So I square root the first term, I square root the last term, I give one a minus and one a plus. And I have now factored. If you forgot the difference of squares shortcut, 1 and 1 are your possible factors of 1. 2 and 2 are your possible factors of 4. We need them to be 0, so I make 1 a negative. I'm dealing with m's on my first term, n's on my second term. Last example. Ask yourself, can I remove a greatest common factor? The answer is no. All right, so now I have to think about one of the methods that I have. Once you know you cannot remove a greatest common factor, you can use the box method every time. But maybe there is a shortcut. This question also looks a little bit different because it's got exponents of 4. Don't let that fool you. This one here is a difference of squares. Ask yourself, what is the square root of x to the 4th? Hopefully you recall from previous math that it will be x squared. Square root of 81 is 9. Square root of y to the 4th is y squared. So we have our first factors. If you use the box method, it will still work. Ones will give you your factors of the x to the 4th. 9s are your 81. We need 0, so 1 gets a minus. What you might have struggled with is recognizing that you needed the squares on each term. But we have one little problem. This is not factored completely. Can you see why? In that first factor, the x squared minus 9y squared, those are both still perfect squares. They can still be factored further. Square root of x squared is x. Square root of 9y squared is 3y. 1 gets a minus, 1 gets a plus. Some of you might say, well, we can do the same thing with the second one. They're still both perfect squares. But they're separated by a plus sign. So they are not a difference of squares. So it cannot be simplified further.